Greetings again, this is Scott, Cantaloupe to Some, with part 2 of how to create Platonic Solid geometry in the Canvas API. So I'm doing a cube this time, if you're following the series, and this is going to be a different kind of cube than the one I previously documented in an earlier video about how to make a cube. This one's going to be kind of a shorthand version, quick and dirty cube with some a little bit of code golfing involved, if you know what that is. It's a shortening of code to fit it into the smallest space possible. So it might look a little bit cryptic, but I'm going to do my best to explain what's happening with the code. So here goes. And it should be a very short video because of that. So again, we have the basic canvas shim that I've been describing all along with the responsive canvas. And to begin, I'm going to comment out the tetrahedron that we did in the last video. And it's noteworthy that that's the only change I'm making at this time. We're keeping the draw function, which I described previously as being standard and universal for the types of objects and models that I use in my programming. So it doesn't need to change, and that's very handy. I don't need to recode a whole drawing routine just for this new cube. So you'll see what I have here. I've got a few different variables in the cube function. It's going to do a similar thing as the tetrahedron, and that is it's a function. It's going to be called and return an array of polygons, basically. It's got 5 variables. They're scoped, and scoping is a bit of a conversation. Not going to get into that, but it just means that nothing outside of this function is going to be affected by the values we assign to these variables. It's contained within the function. And those are ret, which you should know by now is a return value for the function. It's going to spit out some data, an array. And I've got A, B, I, and J, and you may recognize I and J as being iterators. They're called iterators. That is, they're the variable that gets incremented in a loop. And what's happening right now in this one-liner, it's basically a one-liner, and it's going to loop through I 6 times, because we have 6 faces. And directly after that, it's got J equals 4, so it's doing 4 vertices per face, which makes sense. And it's just a real condensed version of the same thing we've been doing, except it's all in one line, and there's your sine and cosine geometry there with the data being generated on the fly. You've got an array right in the middle called A, and it's basically one face, but it's if you see what L is doing, if you look closely, it's switching from -1 to 1. So we're drawing half the cube, and then we're just flip-flopping when I is less than or greater than 3, and it draws the other half of the cube. So it's kind of a little quick, dirty trick. And then the other little piece of magic here is the index. So arrays have index is a big conversation, but arrays will have an index, which means which element you're accessing or writing to, and that index is going up by 1 each time I is incremented. So you end up with a cube, and you can stare at this thing and it might make sense to you. I'm not sure if I can explain it better than that, but it's a little piece of magic that I like to use a lot, and it's real small and compact, and there's the cube. That was super easy. So if you have any questions, my contact information is where it usually is. So thank you very much. Have a good day.